Alrighty, it is time for our probability and puzzle video. And so I got a number of things open here. We got the textbook, we got the Khan Academy assignments, and I looked at the assessment questions for this week to make sure, yeah, everything is as fair as it can be, and you're provided all you need. But you still got to do the work. Okay, so let's talk about it. I have the textbook open. We worked on it today in class, but let's look at the keywords. So we got probability. Of course, you need to know that the measurement of how likely something is to occur between 0 and 1. We talked about you can write that as a number, a fraction, or percent. We see that. You see those three right here. I also need you to have in your notes right now, I have it up here so you can write down these words and their definitions: trial, outcome, event, sample space, and experiment. So all of these bold words should be in your notes. Let's talk about it. Trial is every time you run the experiment. So if you flip a coin 5 times, that would be 5 trials. The outcome, sticking with the coin toss example, the outcome would be heads or tails. A set of one or more possible outcomes for a trial is an event. So the event could be heads or tails. And the sample space is the set of all possible outcomes. Your sample space would be heads, tails, and the event could be the heads or the tails that happen in your trial. Okay, so we're going to be using having questions that use that vocabulary. Okay, so then we did this in class. So now let's go over to the Khan Academy, and I'm going to pick, there weren't a lot of traffic light questions that people asked already, but you guys did a lot of work. So I'm going to go over the top 2 frequently missed questions, but not this one because we did it for the warm-up. So let's start here. Okay, and if you understand it now, that's good, but let's still take notes on it and include it in your notes. You roll a fair 6-sided die. So what is the probability it's not 3? First of all, let's write out our sample space of what it could be, of the set of all possible outcomes. And then we get to do these curly Q brackets called our sample space. So if we have a trial, right, we roll the dice, the die. What is the probability that's not 3? That's the probability that is any other outcome. So 1, 2, 3, 4, 5. There's 5 other outcomes, and there's 6 total outcomes. The total is always in the denominator. I'm going to say events that fit description, just in case you can't read my writing. So this is what we want. We want events that are not 3, outcomes that are not 3. And there are 5 of them. Okay, any questions? You're going to have to ask them in class because I'm moving right along. We did this one for the warm-up. So here we go. Our second one for the video is right here. Mrs. Avery is going to randomly select one student from her class to read a poem out loud. There are 15 boys, write that down, 15 boys and 13 girls. What is the probability that she chooses a boy? So again, we got our total outcomes on the bottom. Going to have to add those numbers together to get the total outcomes. It's 28. And the number that fits the description, 15. It's 15 boys. And that's it. All right, so that's simple probability. See, 15 out of 20. Okay. Moving on to experimental probability. Oh boy. Okay. So here we're talking about Well, let's read it. So far, 907 of the 1,223 voters have agreed to the new amendment. Based on this data, what is a reasonable estimate of the probability that the next voter does not agree to the new amendment? Okay, so let's get our probability. So we want the probability does not agree. We're going to pick someone and they don't agree. So far, these people have agreed to the new amendment. How many people have not agreed to the new amendment? Out of the total, we must subtract the amount that agreed to get the amount that have not agreed. So that is what I will do. 6, this is 1, this is going to be 316 people. So 316 people did not agree. 907 agreed, and that adds up to 1,223. So I'm going to say 316 out of the probability that the voter does not agree is 316 out of 1, 2, right there. What do you think? You think I'm right? Let's see. I'm right. Okay. Don't be arrogant. How much? Okay. Oh, I'm not looking at the answer. Don't worry. I think this one through. Okay. The following frequency table summarizes the number of children that dads in Dad's Club have. Well, based on this data, what is a reasonable estimate of the probability that the next dad to join Dad's Club has fewer than 3 children? So it's really helping me to write, what the question is asking in probability notation. The probability the next dad to join Dad's Club is fewer than 3 children. Fewer than 3. So, so new members with frequency table. Okay, so we have all these members. There's 6 new members that have 1 child. There's 4 new members that have 2 children. And then 8 have 3, but we're looking for fewer than 3. So there's a total of 10 new members that have fewer than 3, 1 or 2. How many new members are there altogether? So that's 10, 18, if you add 18, 19, 20. 20 total new members, just adding these numbers up. And the amount that have fewer than 3 kids are 10. It's looking like half the new members, right? Half the new members, or 50%. And again, I did not look at the answer, so let's see. Whew, okay, I'm right. So we did that. So that's experimental probability. We are finding the probability, and then that's basically it. We just have some real data rather than just actually that's kind of real data too. But something, I guess the big difference here is you're looking for could, it could be, or it could be the not, it could be the opposite of what it says, and then you have to do some subtraction. Okay, I can't use this one because that one's on the progress check. So let's do this. Ella, Danila, and Sophia are competing in an eating contest. Their probabilities of winning the contest are as follows. And again, we can write probabilities as percent, decimals, and fractions. So this whole comparing probabilities is really just challenging you to understand how to compare those 3 different forms of a number. But you can do that, just get them all in the same form, right? So what is your favorite form? Is it fractions, percents, or decimals? I can't hear you, so I will use my favorite. and that is going to be decimals. Okay, so 0.75 is 0.75. 5% is a decimal, is 0.05. Just divide it by 100. And if you ever want to write a fraction as a decimal, just do side work over here. I put the denominator on the outside, the numerator on the inside, and then I do the long division. And 5 does not go into 1. So I add a 0.0, and 5 did not go into 1. How many times does 5 go into 10? 2 times. 2 times 5 is 10. And subtract, and you get 0. And so the answer is 0.2. And I'm going to put an O there so that not only am I comparing decimals, but they all have the same amount of place values. And we can clearly see that Danila has the least chance of winning the eating contest. She will be first in the list. The next person, Sophia, 20% chance of winning. I like to write them as decimals and say them as percents. Gives me extra practice. And Ella, she has a likely chance of winning at that 0.75. All right, so I think you should be good for that. Okay, and so the last thing is the data and statistics unit test. You should see things that we've already done in the class, but I'm going to do these two questions right now as my last two because 4 people did this question and nobody got it right. 3 people did this question and nobody has gotten it right. So let's do these together. And thank you in advance for all that you've already written down. I appreciate it. The following dot plot shows the number of cavities each of Dr. Vance's 63 patients had last month. Each dot represents a different patient. Which of the following is a typical number of cavities one patient had? 2, 5, 7, and 15. So when I look at this dot plot, obviously 0 is the highest number, but 0 is not in the list. So then we have to ask ourselves, where is there more? And while this is 5 and this is 7, and those are also high numbers, there's more down below. And a typical number is talking about the mean. So if you really have time, you can go ahead and calculate the mean of Dr. Vance's 63 patients. Add all these numbers up and divide them by 63, and you'll get the answer. But just looking at it with our eye, we can see we have a lot here, 0 and 1. And we have, a lot here at between 4 and 7. So the typical number is going to be in the middle. So I would say it's going to be one of these two, like the 2 or the 3. So doesn't give me 3, but I'm going to say 2. Let's go ahead. Always make sure you read through the hints. Now see, look at that. I got it wrong, but that's okay. We're gonna. Oh, I got it right. Okay, look at that. They use a little scale. So if you put the scale in the middle, you can see the 5 would make the scale tip over. This is an amazing explanation. So of the choices, it's reasonable to say. So you can take my circles and in the middle, or you can, it looks like a sandwich. You tilt your head side. Okay, but if you do the scale, that's probably an even better explanation. Between the two, me and Khan Academy, hopefully it makes sense. If not, you can ask about it tomorrow. Yeah, I'm not looking at the answer. No. Here we go. At track practice, Alexia ran 5 attempts of the 100-meter dash. All of her times were different values between 11 and 13 seconds, except for an attempt when she tripped and finished in 24 seconds. Alexia's coach said that they would remove the 24 seconds result from the set of these practice times. How would removing this time affect the mean and median? So I did talk about this last week too. This 24 seconds is an outlier because everything is between 11 and 13. So if we add that in, it's not going to be good for her score. Okay. So she has 5 attempts. Let's say it's 11, 11, 12, 13, and the 13. 1, 2, 3, 4, 5. Oh, except the last attempt was 24. So you could do the math and you can see like if I exclude this one and just do these, then my median is going to be 11.5 and my mean is going to be probably 11.5 or 12, right? I don't know. But if I include the 24, now what's my median going to be? Crossing off, I get the number. My median is 12. So the median changed from 11.5 to 12. Not that big of a deal. But if you add up all the data points, at 1, 2, 4, 7, and then 11. 1, 2, 3, 4, 5, 6, 7, 71. 71 divided by 5 is now going to be about 14. So the mean was originally around 11.5 and it went to 14. The median only changed from 11.5 to 12. So let me just write that next to each other. The median went from 11.5 to 12 because of this 24. That was the mean. The mean changed from about 11.5 to 14. So that is a 3.5. That's an increase of 3.5. The median only increased by 0.5. So for that reason, we say that the mean is sensitive to outliers. It's sensitive. Is anybody else sensitive? Like the mean, then you're like the mean. It's okay. The median is not sensitive to outliers. So both the median decrease, but the mean would decrease by more than the median. Yes, because we could see that, right? It decreased by 3.5 when you took away the 24. Both the mean and median would decrease, but the median would decrease. No, that's saying the median is more sensitive. Both the mean and median will increase, but the mean will increase by more. No, if you take away the 24, the median and mean decrease. So I kind of did it backwards when I did my math. But you can see if you pause the video and think through it, we're taking away the 24, so the numbers are going to go down. So you see both, they decrease, but the mean would decrease by more. So in my example, 14 to 12.5 or 11.5. All right, so I hope that's helpful and I am done. And so now you can go try to get 100% on all your Khan Academy assignments, post all your traffic light problems, and I will see you in class.